All right, guys, phospholipids. Phospholipids are part of the phospholipid bilayer. There's a page that I'm going to have you make sure that you look at as we move on down. But you have these phosphoacylglycerols and sphingomyelins. It's kind of a weird word, but a phosphoacylglycerol has a fatty acid, and then what's called a phosphodiester, where you have a phosphate group in here. And what you get is this fatty acid chain, and then this phosphate group. So you get a phosphodiester on the left, and excuse me, a phosphoester on the left and a phosphoester on the right, hence phosphodiester. Um, this R prime group or double prime group can be one of two things. It can be this compound right here, this branch, or this branch. If it's this, we call it cephalin. If it's this one, we call it lecithin. Now, sphingomyelins are different. There's a long carbon chain, only one fatty acid, and then we have this phosphodiester again. The way that phospholipids work is this phosphate group down here is charged. And so that's your polar head. And these fatty acids act as your nonpolar tails. And this is how the phospholipid bilayer works. You have the heads on both sides, all right, on the top and the bottom, or the inside and the outside. And then you have those nonpolar tails that form the bilayer in the middle, all right? To move on down here, um, when we look at sphingomyelin, it's derived from this compound. It's not derived from glycerol. All right. And so you get this large chunk here. And instead of ester bonds, you get an amide connection here. All right. It's still from a fatty acid, but this is an amide connection. All right. That's the difference. You can see some information over here. Sphingomyelins contain amides. They form the myelin sheath around your nerve, which is very important. If that becomes damaged, that this is what occurs with individuals with MS. So the cell membrane, you're going to have to look at page 687. That is going to be the whole shebang right there. It's a nice little picture. And here are just some things that we're looking at within there. Cholesterol is embedded within the membrane. There's some integral proteins. There's glycolipids and glycoproteins. Uh, but as far as moving things between the bilayer, there's a couple ways we can talk about this. Simple diffusion is for small molecules that move all the way through. Facilitated transport, this is for large polar molecules, and those integral proteins create channels for them to go through. Active transport, on the other hand, requires energy because you're doing something. It's like trying to push a rock up a hill. You got to put energy in order to get it up there. And so that's what active transport is. All right. So cholesterol is kind of a big deal. This is our steroid skeleton right there. I've talked about this before. We have our 6, 6, 6, 5 membered rings. This is the structure of cholesterol. All right. So you have your A, B, C, and D components. The amount of food varies depending on the food. The cholesterol that we talk about when you get it tested is serum cholesterol. All right. And so what you have there are lipoproteins. This is where cholesterol combines with phospholipids and proteins to make this ball of stuff that can dissolve in water. So you've heard of good and bad cholesterol. Well, in HDL, which is a high density lipoprotein, you get more protein than you get cholesterol. And so it's higher density. All right. Proteins are more easily dissolved in water. Whereas LDL, that's going to be low density. There's more cholesterol than proteins. They don't dissolve as well. That's why LDL is considered bad cholesterol, because you could understand if it's not dissolving in your blood, it can cause some problems. There are some drugs that can stop the production of cholesterol in the liver. These are some of them that you probably heard of: Lipitor, Zocor. Lovastatin, I think, was the first drug that was developed for that purpose. You could see lovastatin and simvastatin are pretty similar there. Just a few, just like this little chain looks like it's the only difference. But this can cause problems if you think about it. You are messing with the biochemistry of your liver, and your liver, if you're wondering where any chemical processes occur in your body, it's usually the liver. And so you don't really want to mess with that.